Hi. So in this video, the goal is going to be to make a first-person shooter controller. Well, really a first-person controller. We're not going to deal with like the shooting part of it, but we want to be able to walk around. We want to be able to jump and sprint. Before we can do that, or the main goal that we want to accomplish while doing that, is to learn about Unity's input system. So for the last few projects, the way we've been doing it is if we wanted keyboard input, we say keyboard.current and then specify the key that we want. Or, we'd say mouse.current, specify like what we want from the mouse, either it's position or the left or right click, we would get like the keyboard and the mouse and then actually go ahead and like try and read it. But what happens when we want our game to support controllers, for example, right? Do we have to go into the keyboard, check for the event, or the mouse, or I'm sorry, or a controller? It's gonna make our code go that even bigger. What happens when we want to have rebindable keys, right? It starts to become more and more complicated. The more accessibility that we want to offer for how our players can play our game, whether it be keyboard, controller. What if they have an Xbox controller versus like a Nintendo Switch controller or a PlayStation controller? These are all like different devices, and we want our game to just work with everything, right? So, in most modern game engines, specifically in Unity and Unreal, they have come with a way of dealing with that, which is to separate our inputs from the rest of our code. And this is known as the input, action, and kind of mapping system that's there in both Unity and in Unreal. They both use like different terms kind of to describe these things. They both have different asset types for them, but it's basically the same thing. The idea is that we separate out the actions, moving, looking, jumping, crouching, swimming, from the buttons themselves. So WSAD versus left stick, by separating these two, we can kind of mix and match them the way we want to. We can make it easier for our players to customize their controls. We can make our game support multiple types of controls, very easily. And so let's take a look at that. If I was to go back to the asset folder, one of the things that Unity just has by default is called this input systems input actions. This thing should have just been added by default to you guys. And when you look at it, we can see here on the on the leftmost side, there's something called action maps. It says player and UI. And then there's a bunch of actions underneath it. So under player, there's move, look, attack, interact. This is just default. It's not like specific to any game. These are just things they added. And if we click UI, there's navigate, submit, cancel, things that more relate to a UI, right? So what's nice is we can switch our action mapping based on the context of our game. If our pause menu is open, we might be in UI mode. If our pause menu is closed, we're going to be in player mode, like the player's playing the game. If, for example, we had a game where our player could get into a car, into a plane, we could have the same controls mapped to different contexts. So if they're in the plane, maybe W and S will. I'm sorry, if they're in a car, W and S would accelerate, decelerate, A and D would turn the wheels. Um, And when they're not in the car, WNS is going to move their player forward, backward. A and D will move left and right. Maybe in a car, spacebar is going to be a handbrake. So in the car context, if we made one, we can make space a handbrake action, but space would be jump when we're in the player mode, right? So it helps us separate those things out. Let's make one of these. I think that would be the easiest way to kind of see how Unity has made their default one. So what I'm going to do is close out of this. We're going to right click in our project browser, create, and then all the way at the bottom, not under any folder, there's going to be input actions. We're just going to create one of those. And I will call this one FP, or I'll call it input system underscore FPS for my first person shooter game. We'll go in here and it's going to say our list of action maps is empty. So I'm going to add one. I'll call it player, just like how Unity's did. And here we can see we can add actions. Remember, actions are not the buttons themselves. There are actions that our player can perform with the use of these buttons. So moving, looking, jumping, sprinting. Those are actions. And so I'm going to add the ones I want, which is really going to be what I said. So moving, looking, jumping, and sprinting. So I'm just going to hit this button 4 times and then rename them all. It shouldn't call it moving. It should just be move, look, jump, and sprint. The naming of these is very important because you are going to reference these things in your code as like a string. So you have to type these names in. So again, just find a convention that you're used to like having. I start everything with a capital letter. So I know that, so I can keep that in mind as when I type them in our script. Next, the move, for example, the move action. If we come to the action properties, it says action type button. A button is just a boolean essentially. It's either on or off. Our sprinting, our jumping, that's going to be, for example, spacebar for jumping. You're either pressing spacebar or you're not, right? It is an on or off. So it makes sense that the button type, or I'm sorry, the action type for my jump is a button. Sprinting as well. You're either holding sprint down or you're not, right? So it makes sense that it's on or off. It's going to be a button. Moving and looking, however, when I move, um, on a keyboard, we would press the W, S, A, D keys to move. But on a controller, for example, we'd use the left stick to move, like the left analog stick, right? And that left analog stick is not just a button. It is actually an axis, right? You can move the left stick up, slightly up. You can move it fully up. You can move it slightly down. You can move it left, right. You can move it a combination of these. It is an axis. Our left stick, for example, is made up of two axes, the x and the y axis. When you move it up and down, you're moving it on the y axis. As we move it to the top, we're going from 0 to 1. When we move it downwards, we're going from 0 to -1. Same on the x axis. When you move it right, it's going towards 1. When you're moving it left, it's going towards -1. So our left stick, our movement really, is not a single button, but it's a range of values. And so if I drop down this button, I can choose value because that is what it is, right? It's not a button, it's a value. And then it asks us what is a control type. There's a bunch of them. If you just had one axis, it would be something like axis. You could do integer if you didn't want, if your thing was 0 and 1, but you didn't want to have any of the in between values. But in our case, our movement is a vector 2, right? This move, this left stick, or this WSAD, it's really two axes. So I can say vector 2. Same with our look, right? We can look up, down, left, right. So look is also a value of vector 2. With that, let us go and bind the buttons that we need for for this input system. I'll start with jump. Jump is just going to be spacebar. So I could click on this path, go to keyboard, search here for spacebar. It's a spacebar keyboard, and I could select that. That's one way of doing it. Another way of doing it is, so I'll show you with sprint. I could click the thing. I could just click listen. Now it's going to listen for a button press. If I click left shift, it says left shift on the keyboard. Or you could also do both shifts generically, but in this case, sprint is going to be left shift. Another nice thing is if I was just to grab my controller here and I click, I add another binding to jump, click path, I can click listen. I'm going to hit A on my controller. And there you can see it says button south, which is the bottom button on any generic gamepad, or A on an Xbox controller, right? So I can add that in there. And now my game has both controller support and keyboard support. All I need to do is set these buttons here. Next, let's do look. Look is going to be my mouse delta. It's just going to be the change in my mouse's position. And finally, moving. Um, and real quick with the look as well, I could just add a binding. I could hit path. I could listen if I move the right stick on my gamepad. There you go. We just added support. So it's very easy if you wanted to add support for your controllers. You can just do it here, and we don't even need to worry about it in code. The code is going to be the same. We can change our controls as much as we like over here. And finally, there's looking. So our mouse is a 2D axis. For moving, if I was doing movement on a controller, I could just add a binding and then use the left stick, right? That is just another axis. It's a 2D axis. I can move my left stick around like that. However, our keyboard isn't quite like that, right? WSAD is a set of 4 buttons that we want to turn into an axis. So we can add a binding, and you can see that the second option is add up, down, left, right, composite. What composite really means is it's going to take these up, down, left, right buttons and turn it into an axis. So you'll see when I added it, it says adds a 2D vector. I could name them, I could rename it WSAD just so like I know exactly what this composite is. And then there's a binding for up, down, left, and right. And so really up would be W, down would be S, left would be A, and right would be, oops, right would be D. And so what this means is when I press W, it's going to send out 1 on the Y axis. When I press S, it's going to send out 1 on the negative Y. A and D will send out, -1 and 1 respectively on the X axis. So we're just taking these 4 buttons and turning it into a vector too. Okay, awesome. So let's save this asset. Let's get out of here. I'm going to make a new script, set a new folder called FPS, and I'm just going to make a new script that's going to be called input manager. This single input manager script is where we're going to get all our inputs, and any other class can like read from here. So like this input manager is just going to get all the inputs and keep track of them for us. That's all it's going to do. It's going to get the input. If spacebar was pressed, there's going to be some variable that keeps track. Okay, spacebar is true right now. Spacebar is false. So that any other class can read this input and then act on it. So to start, let me make some variables that I need. The the main thing that I need is going to be that input action asset. That input action, that asset we just made where we defined everything. I'm going to need a reference to that. Before I do that, if your IDE doesn't automatically add the import statements, I'm just going to make sure we're using Unity Engine dot input system. This is just to make sure that we're using the new input system. So I'm going to make a serialized field, call it input action asset. I'm sorry, that's the type. And I'm going to call it my input actions. So that is the whole asset that we made, right? With the player, and then we had move, look, jump, and sprint. So now we need to kind of get references to all of that. So I will, I'll make variables here for them as well. So we'll have a string that's going to be our action map name. This is just to keep things a little more organized. The action map that I'm going to be using was called player. I will have a string called move action name, and that's going to be move. And just like that, I can add a string for all my actions. And the only reason I'm doing this is because later on, if I end up using, or changing these, I only need to change the value here, and then it reflects everywhere else in my code. I don't have to go around looking everywhere that I use the word look or move. So it just makes sense to turn the string into like a variable of a string. So we'll have jump. And finally, we will have sprint. Oops. String sprint. Okay. I'm going to get rid of start and update. Next, we need a reference to every single input, every single action. So this string is just storing the name of it. This is just for us to use later to make it easier in case either I misspelled something or something changes. But I need a reference to the actual move, jump, those things themselves. Those are specifically called input actions. That's what the type that is. So I will have one for my move action. I will have one for my look action. I'm going to have one for my jump action. And I'm going to have one for my sprint action. And then the other thing I need a reference to is the action map itself. Again, we have the name here called player, but we need a reference to the input action map so that it knows where these input actions are located, right? Again, I could have like multiple different input action maps. So we need to get a reference to the correct one. And so I will just call this map. Okay, and the last thing that we need is some variables to hold the values of these. So whatever move action is, I need to hold it in a variable. That way someone else can read that variable. Some other script can read that variable and, use that input somehow. So for that, I could make a vector2 move, right? So this is vector2, it's going to hold the move. Other classes need a way to get this value. They cannot change it. I don't want them to change it. So if I made it public, for example, I could I could read move from other classes, but they can also change it. And that's not good, right? I don't want anyone else to change the input classes variables. That should only be done through the inputs. So I could make it public, but that's not going to work. I could also, just make a function. I can make a public function get move. And here it would be a public vector2 get move, and it would just return move, right? So anytime instead of calling, like I could just call this function from other classes and then get move. This way, other classes can read it, but they can't set it. This is a very, very common thing in programming, right? Either you want other classes to not be able to read it, only set it. You want other classes to be able to read it and set it, or you just want other classes to be able to read it, right? Reading and setting variables is a very like common kind of thing. And so C sharp and really all these programming languages have something called a getter and a setter function. It's kind of as the name implies. A getter just means we're getting the value, and a setter just means that we're setting the value. And so a shorthand of writing that get a public get function, like a getter, is just making this vector to public. I should name it move with a lowercase m. And then we put parentheses, we say get, and we say private set. So all this is doing is when we make a variable public, what we're actually saying is, hey, this variable, just give it this kind of function that lets us get it and read it, or that lets us set it. So when we say public, we're kind of just adding these two functionalities to this variable, right? So a shorthand of saying that I only want either the setter to be public or the getter to be public is make it public, and then use this format to say get and private set. So that way we're saying the get function is going to be whatever this is, which is public, and then set is going to be private. So we can only get this variable. And the reason this is better than writing a function is I am going to have, 4 of these input variables to hold my inputs. That would be 4 functions. If your game starts to get more complicated, I'm sure you can imagine 8 buttons, 9 buttons, 10 buttons, that's going to be more and more just to rewrite those functions. Is a great shorthand. Not only does it save on typing time, but also it's easier to read your code, right? It's not just there's not just a bunch of unnecessary functions there. So just like that, I'm going to add in all the variables I need. So it's going to be another public vector2 for look. And same thing, right? Get private set. I'm going to add in a bool. That's going to be sprint. And same thing, it's going to be get and private set. And finally for jump. Okay, so I will add a public bool jump pressed. I should just call it jump. Okay, awesome. So now we have all the variables that we need. We now need to, in the beginning, like when we start the game, first thing we need to do is look for our input map and then get all the actions. So you could do that in void start, but instead I'm going to do it in void awake. And the difference between start and awake is start is called when the game starts, but awake is called whenever the variable is active. So sometimes in the previous project, I remember we set a game object to be, we set its active to false, then we set it to true, then we set it to false. This awake is called every time that set active is true. So I will take my map and say input actions dot find action map. So from our input actions, which is our asset that we're going to set in the inspector, we're going to find that map. What is the map's name? It's going to be called action map name. Next, once we got the input action map, we can get all our input actions. So move action dot map dot move action is equal to map dot find action. And here we want to find the name, move action name. And just like that, we want to do it for the rest of them, right? We want to have our look action is equal to map dot find action, look action name, jump action. Which should also be sprint action name. Okay, so we've got our input action, we've set the map, and then we've set these four actions to their correct thing. And then I want to set these actions, right? I want to go move action is equal to map dot. Oops, sorry, I just did this part. Sorry. I want to set okay. Sorry, I got a little confused there. But what I want to do is now we have these actions found, and I need to when an action happens, just like when we do a button press, an event is run. So I need to every time these move action, look action, anytime these actions are fired, I need an event to bind them to. I need a function that's going to run when these happen. Instead of doing this on awake, I'm going to do this on enable. It's another special function we have that Unity has, and oops, it should be on enable. And yeah, on enable. And I had made a mistake earlier. I used awake here when you could have used start here, and I had described awake as a function that runs every time we disable and activate the object. Uh, that was a mistake. On enable is a function that runs every time we start every time we set the active to true. So when we turn it off and set it back to true, on enable will run. On enable is going to run every single time we do this. Awake is just a function that runs before start. It's just there though that we can organize our code a little better. So awake runs first, then start runs first. Here we could just use start. That is perfectly fine. That was my mistake. Okay, on enable, I'm going to assign these functions as listeners to the events that move action, look action, jump action, sprint action all fire when they happen. So before I do that, actually, we need to. So when we use our input actions, we can only have one map enabled at a time, one action map. So we need to enable our action map. Currently, map is equal to our player action map. So every time this object is enabled, we want to set map.enable. That way we know we're using our player action map, right? And it's gonna, it usually starts as disabled. If you don't have this line, it's gonna give us some errors. Next, we want to say move action, and there's two events that it runs. There's performed. There's performed, and there's move action dot canceled. And we know that these are events because, and if I was just to rewrite this performed part, you can see it might be small, but it has a little lightning icon to show us that it is an event. So when my performed happens, I want to run a function based on that, right? So in this case, when move action dot perform is run, I want to maybe run a function called on move, just to say that I'll call it void on move. And here, I just want to take whatever value this move action passes and then use it. So for move action on perform, just like we did on the button, I could say plus equals to and give it the function that I want. So we're adding this function as a listener to this performed action. You can see that when you do this, it's going to give us like a little red error, and it says that we need a parameter called input action or type input action callback context. So we can add that here, input action dot callback context. And what this callback context contains is all of the information about that input. I will call it context. And really, all we want to do is set our move action to our context, which is again the information about this input dot read value. All of the functions inside the context, for example, this read value, uh, all the functionality in here, read value, or was pressed this frame. This is all the same stuff that we had seen when we use mouse.current or keyboard.current. This context just contains um, all that function or all that information specific to this input. You'll see here read value does give us an error, and it's because we need to tell it what type that we want to what type we want to receive when we're reading this value. So in angled brackets, I want to say vector2 because that is the type of value that I want to read. And I'd made a small mistake there. I had used move action here, but I just wanted to use this vector2 move. But there you go. So now whenever this action is performed, we're going to set on move, or we're going to run the function on move, which is going to get this context, which is just going to set move to whatever the value was inside that context. Even when our move action is canceled, so when we stop pressing any button, I want to run on move. And like that, I want to go ahead and do this for all the other functions. I want to do it for my move. I'm sorry. I want to do it for my look action, my jump action, and my sprint action. Okay. I just went ahead and typed out everything because I didn't want you guys to sit here while I typed all this out. All I did was just like I did the move action. I made sure my sprint, my look, my jump, I made a function for them, and I've added the event listener. I've assigned it. I've used that plus equals to assign that function to this event. So this on enable is going to run every time that game object.set active is true. There is a chance, like when you're making like a complex game with maybe a lot of different types of inputs happening, there's a chance that maybe this input manager is going to be disabled at some point for another one, that's more specific to its context. And so if we have enabled it, we've assigned these functions to these events on disable, so that's the opposite of on enable, we just want to unassign them. And that's done the same way, except instead of plus equal to, instead of adding it, we're going to say minus equals to. We're just going to remove it. So this is just good practice, for Unity's input system. If we're enabling these or if we're going to assign some listeners, let's just unassign them when the object it isn't like being used anymore. And then I made an on move where we just read context vector 2. This one we saw together. I did a debug.log move. Same thing. I did look. I did just read the values of vector 2. On sprint, I'm trying to read it as a boolean, right? Because it says that we just want to put the type that we want to back in. Trying to read it as a boolean. And then jump's a little different just because movement, looking, sprint, I care whether that button's being currently held down or not, right? Sprint, as long as we're holding it, we're going to be running. Looking, it's just going to happen every frame. Same with moving, right? Even if we're not moving, that 0 movement, that's important for us to know. Jump is a little different because I don't want my players to jump if they're holding spacebar. I want them to tap it. So when they land on the ground, if they hold spacebar, they jump. They're still holding spacebar, they land. They have to let go of spacebar and tap it again to be able to jump. So instead of using read value, just like we had on the keyboard, I could say context.action.was pressed this frame. So only the frame that it was pressed, it's going to return true. And then I've added debug.log so we can just take a look at all of this. So let's go back into the editor and take a look at this. I made a new input manager game object and just assigned this script to it, and then just assigned our input action to it. You can do that by hitting this little circle here, and you should see all the input actions. This one's Unity's default, this one is ours. So gonna hit play. And then you'll notice the first thing, as soon as I start moving my mouse, it's gonna be printing out that mouse delta. So that's that mouse input, right? The look input. I'm gonna let go of my mouse, I'm gonna start pressing WSAD, and now you can see it's gonna be adding to my WSAD input. It's not gonna be adding more, but if you look in this corner where it says the amount of time something happened, I'm starting to spam WSAD. Or let me just uncollapse it for now. But now if you can see the feed is being spelled with move as I'm tapping WSAD. With spacebar, when I tap space, I'm holding it. It says jump is true. When I let go of it, it says jump is false. It's only happening that one time the frame it was pressed or the frame that was released. It's not happening as we hold it. And then finally, the sprint, right? If I tap sprint, I'm going to get an error. It says invalid operation exception, but the main part, it says cannot read type of value Boolean from control. So what it's saying is that even though this thing was telling us to tell it what type we wanted as variable to come back as, it really only accepts like numbers, like int or float or vector 2. It does not accept Boolean. But that's easy enough. I can just make this a float. And really, the float is going to be 0 for not pressing the button. It's going to be a value greater than 0 if we are pressing the button, right? So I could do something like this, where I could check if the context dot value was greater than 0. If it is greater than 0, sprint is true. Else sprint is false, right? So it's always 0. If it is 0, it's going to be false. If it's greater than 0, it's true. Otherwise, it's false. We could type this out, or a simple shorthand is just check, is this float greater than 0? And if we just try and isolate this statement, this evaluates to a true or a false, right? At any moment, the computer can look at this. Even I could look at this and say, oh, this is true or this is false. And that's what the computer is going to do. It's just going to evaluate this to true or false. And we set that into our sprint. It's just an easier shorthand way instead of typing all of this, but it's essentially doing the same thing. So let's save that and go check it out. And now, if I hold shift, it's printing true. When I let go, it prints false. And awesome. Okay, there you go. Just like that, we now have our input controls. We have an input manager. We can add as many inputs as we want. This control system also works with my controller now. I don't have to worry about anything else. And when we get to making our first person character, we're going to use this input manager so we don't have to worry about like reading the inputs in the first person character. We just read these values and then use them. But I think I will stop this video here, and then in the next video, we'll continue and make our simple FPS controller. Thank you guys for watching.